known as Deliblato Sands in Serbian language. It's a little bit harder to pronounce. It's called Deliblato Peščara. But this is the area which is located in the southern part of Vojvodina province area, the area which is lies along the Danube, partly on the Danube, but actually it is very sandy area, which in the recent history shared the same geomorphological characteristics like many deserts in the Danube, in the Europe and in the broader region. Today, this is the last remains of the sun deserts in the Europe, and actually almost more than 20 years it has the status of protected area. Actually, we are speaking about one of the biodiversity hotspots in Serbia, and in this context, Deliblato Peščara is recognized as a special nature reserve, the area which is designated by the government of the Republic of Serbia. The area is quite known in the scientific, let's say, circles, known as area which is also in the focus not only of the researchers but also of the practitioners, and area which is little bit typical from the rest parts of the Vojvodina province. Vojvodina province is the agricultural land, and this area stands as some kind of island, let's say, with the ecological characteristics, with the hydrological characteristics, with its biodiversity characteristics, and let's say that has very good position in terms that it's some 65 kilometers from Belgrade, some 130 kilometers from Novi Sad, which are the biggest cities in this region. Speaking about some international designations and labels, we can say that despite the fact that the Deliblato Sands is the area which is designated by the national government, and it has a total area which covers a little bit less than 35,000 hectares. It is also recognized as international area important for birds, international area important for plants. It is also the Ramsar site. It is part of the European Green Belt, and it is also part of the ICPDR. So the manager of this area is actually public enterprise Vojvodina Šume, that's the state forest-owned company, which also has some which has the managerial ingerention or function in terms of this area. So this is actually the map of our area. The area is, we have certain parts of the area which is let's say represents like a core zone of the area. This red color on the area is actually the area where there is no human interventions. The yellow color on this map represents the, let's say, some buffer zone, or we call it second regime of protection. This is the area where certain human activities which are focused to the revitalization of the habitats and the species are allowed, and the rest of the area, which is covering more than 70% of the total surface, is the area where we have the sustainable use of the resources. It is very interesting that this is the area which is used from the aspect of different economical branches like the forestry, hunting, fishing, tourism, but the primary focus is actually the nature conservation. This is the habitat map of the area. So we have very, as I said, diversity of different habitats. I'm not going into the detail. We have the mosaic or combination of different ecosystems from forest ecosystems, steppe vegetation, salty vegetation, or salty habitats. We also have the wetlands in the area which is closer to the Danube. So these make unique combination in terms of the value, ecological value of the area. Some of you already visited this area. For those who didn't, this is kind of invitation when you come to Serbia to visit this area. We think that we have something which is unique, which is ordinary. I see Crystal is already knocking with the head, which means that it confirms that it's not the area which is typical, also typical for Serbia, but it's also the area which is very unique in some European context. The area has quite a good access, which means that it can be entered from the different sides. And the inside of the area, there is a very good network of the forest roads. Why this is important, we need to tell, at least I need to tell you that this is one of the most endangered area in Serbia and within the territory of Republic of Serbia when we speak about uh, fire protection. So if not on the first place, but at least on the first three locations in Serbia, which needs quite big and more attention when we speak about forest fires. In some recent history, since 1997, we had several big fires that have occurred in the area, and this is the reason why this dense network of the roads, forest roads, is important for this protected area. So we are dealing with a quite big surface, as I said, more than 35,000 hectares, and we need also good possibility to access the area in terms of the fire occurrence in order to prevent the spreading of the fire. In 2007 and 2008, we had, let's say, the last occurrence of big, let's say, big fires that spread on the big surfaces. The largest one was in 1997, when we actually within the 1 or 2 days we lost more than 3,000 hectares of the land. And with this experience, we also enter also in this project with the intention just to prepare ourselves in terms of for not fire prevention, but getting the data which could help us not only in the context of fire prevention, but also managing of the different resources. First of all, the forest, the wetlands, and the pastures. Deliblato capacitors also rely on several villages which surround this area, which also makes significant pressure in terms of the use of the area. And in this sense, also the CiROCCO project is very important for us. Additionally, since we have the protected area which is close to big cities and also to the big power plants in the neighborhood, for us it's very important also to monitor the air quality. We know that the air quality in this area is very good, and which confirms the data from the existing hydrometeorological stations. But what we want also to achieve is to monitor the air quality, since that we have the biggest city in Serbia, which is in near vicinity, is also the power plant which operates also in the near vicinity of the area. Additionally, that's also focus of our project, as I said. So we know that our area is area which shows very big extremes in terms of the temperature. So during the summer, you have more than 42 plus degrees. During the day, during the night, you have less than 10. So these big oscillation of the temperature is very important in terms of vegetation. And for us, this is very important also in the context of the prediction of the fire risks and the droughts. So we need to focus ourselves for the future management also in the context adaptation in sense of the ecosystem adaptation, adaptation of the species and the ecosystem of the habitat in order to provide the best possible response to the current climate change issues. Additional one, as I said, we had the big pressure from the nearby settlements, which are outside of the area, but since the Deliblato Sands is actually surrounded with agricultural land for us, this is also very important to see possibilities how to prevent the different environmental degradations and potential desertifications, and as I said, the influence of the different pollutants which are around the area. Within the project, Miniature will tell a little bit more than about this is that we set the network of the sensors on the area in order to cover the whole area, which was for us was quite demanding in terms of setting the let's say not so big number of the sensors in order to cover the whole area. But I think the major issue was the lack of the electricity, the lack of the different communications channels. First of all, the signal, mobile signal in the area. So that was the major issue that we try to overcome within the project. And these are the actually only like three main points for the dealing in the project. This is wildlife risk mapping system, the drought risk mapping system, and also the land and vegetation sensitivity. Miniature will give you more details regarding this.
Great, thanks. So try to go briefly a few slides. The vision of CiROCCO, first of all, we aim to establish an integrated sensing system. It is composed of a distributed network of low-cost sensing nodes. They are coupled with off-the-shelf solutions and state-of-the-art data fusion that is foreseen in CiROCCO, remote sensing and assimilation modeling techniques. We aim to monitor areas where there's a lack of ground observation, desert areas, and offering a solution that is easy to maintain and expandable and flexible. We foresee commercialization services to ensure the sustainability of the installation, and we foresee fair management of data and integration to the cross-Copernicus ecosystem. So we have 12 partners coming from 7 countries and joining forces for this project. Here you can see the geographic distribution of the partners coming from Europe and from Africa. We have from Egypt. The duration of the project is 42 months and it is ending end of August. So the main objectives, there are business objectives, technical, scientific innovation, and impact maximization. Starting with the business objective, the installation and operation of in-situ low-cost standalone electronic sensing nodes is a high priority, and we want to ensure the interest from local communities in terms of where these sensing nodes will be installed and their operation. One of the technical objectives has to do with the establishment of this network of low-cost, sustainable network of nodes in undersampled desert areas and ecosystems in Egypt, Serbia, and Spain. And the second technical objective has to do with the development of data processing services that is based upon ICT infrastructure, and that aims to further improve their quality of monitoring, foreseeing also data fusion services. Scientific innovation objective 1 has to do with the enhancement of climate change models that will make use of datasets coming from our system and in support of the research for the European Green Deal challenges. And the second scientific and innovation objective has to do with the integration and assimilation of cross-Copernicus ecosystem. And one impact maximization objective has to do with the acceleration of the adoption of CiROCCO solutions, tools and services by the wider community, so to ensure by that way maximization of the project impact. In this figure, you can see the concept of CiROCCO. You can see that we foresee a mix of low and high cost sensors and data fusion services between high and low end sensors. We also foresee data fusion between Earth observation and in situ measurements. In terms of communication, for communications foreseen for our services, we foresee wireless and satellite communication for data collection. And in the end, the data sets that will come from monitoring specially identified parameters will serve the needs of 4 different pilots, 4 different services: air quality early warning system for human health, renewable energy system planning, land use and ecosystem management, which is our pilot in Serbia and where we will focus on today, and modeling of greenhouse gases and particle emissions. Here you can see the number and the characteristics of the different sensors that are used in CiROCCO. We have higher quality mid-cost stations, these AQMS stations, 9 distributed in our 4 pilots. Portable devices, aerosol optical depth devices, 6 of them, that carry 2 self-photometers. And we are design manufacturing, and ensuring the operation in the field of 60 low-cost sensing nodes. They're custom-made nodes. Here you can see the list of parameters that they are measuring that have been designed, as I said, and in the framework of the project, so as to cover the needs of the 4 different pilots. In brief, the outcomes, we want to monitor conditions in 3 desert regions for a period of at least 10 months. The whole area expands over 2,000 square kilometers, 69 stations in total, 10 parameters measured. Actually, we have 13 parameters measured currently. We aim to have our low-cost sensing system to make it available to the market at with a 60% lower price than the current market. The validation of the data sets through their application in the 4 different pilots that I mentioned before. We aim to offer increased accuracy, improved by 10% with our in situ data sets, and collaboration with at least 5 working groups of GEO, Copernicus, and ESA, promoting our in situ component, which is one of the targets and challenges, and we are working on that. And here you can see in this last slide an overview of the geographic distribution of our 4 pilots. So the first one, renewable energy systems planning, it is at the Ben Park solar park in Egypt. The second one is desert dust storm events monitoring in Cyprus. The third one, our focus today, is our pilot in Serbia and at Deliblato Sands, sustainable environmental restoration support at Deliblato Sands. And the 4th pilot, modeling of greenhouse gases and particles emission at Tabernas Desert in Spain. So that was in brief what we are doing in the project, and we are looking forward to Miniature presenting us the first outcomes from Serbia.
So after the introduction, we saw very detailed introduction about this unique area, but I will just emphasize one big and very important aspect of Deliblato Sands area, and that is the history of this unique natural area. That is a great example of human disturbance effects. So This area was completely open sand just 2 centuries ago due to human interventions and human influence. And this shows the impact that human interventions can have on this sensitive area. So the first efforts of reforestation in Deliblato Sands began in the 19th century. And since then, the area has been artificially reforested. And now it's a very unique blend of different species of plant and animal life, as Ivana said in the introduction. And in the current conditions of climate change and increasing societal pressures, it is facing increased danger of re-desertification, so to say. So Ivana also mentioned one of the greatest problems, that is the drought and wildfire risk. As we know, this is the most fire-prone area in Serbia because of its specific vegetation and sandy soil and extreme temperatures and high winds. We have very dangerous conditions, which resulted throughout the history in many wildfires that left great damage to the ecosystem. Also, we have the problem of environmental degradation. As we mentioned earlier, this area is completely surrounded by agricultural lands and also by settlements. Belgrade is relatively near. We have villages and also mining and industrial facilities in the immediate surrounding of this area. And so these constitute the main land use management challenges: the intensification of climate change, the droughts and extreme weather, which can be observed in the last decade, and also the deterioration of soil conditions and loss of organic matter, and the ever-present changes in land cover and land use with growing anthropogenic pressures, so exploitation of forest and forest cutting and grazing and so on. And also one issue in this protected area is the wildlife. Hunting tourism is actively pursued in this area, and the wildlife also presents a challenge to the vegetation, so the reforestation efforts. About the forest fires, Ivana told some details. I wouldn't maybe repeat all that. We had many fires, but I would show this illustration, which shows the main factor of wildfires in this area. These red dots are fires registered around the protected area, and they are registered by satellite observation. And this is an archive that covers years from 2012 to 2024. And here we have a huge number of smaller fires registered, which were started on the surrounding fields. So despite the fact that this is banned by law, this is widely used, and we can observe year after year this, so to say, illegal activity by the local farmers. So when we analyze the distribution, the yearly distribution, we can see that the peak, so the greatest number of these fires also coincided with the droughts and the very dry years. And also an interesting graph is that is showing the seasonal distribution, so the monthly distribution, which we see clearly that in October we have the greatest number of fires, in September and in March, and this speaks about the origin of these fires that are started because of agriculture. So in order to address these issues, the CiROCCO project is plan this layout of sensors, low-cost sensing networks, which can work in very challenging conditions. So actually, you saw the other partners on this project in Egypt, in Spain, but in practice, our pilot area proved the most challenging, so to say, because of the rugged terrain, the inhospitable climate, with a very big range of cold temperatures and very high temperatures, and also the terrain which is very uneven, so the hilly terrain, which is challenging for the signals, for the sending of signals of these stations, automated stations, that register the measurements and send them over radio connection. So this was very challenging, and right now we are also troubleshooting some of the issues that arose because of this rugged terrain and the difficult conditions. But all in all, we have now a good quality time series of measurements that we measured from last year. And we have the first insights of what is actually happening inside the Deliblato Sands area regarding the fire risk, the drought conditions, the climatic conditions, and also the state of the ecosystem, so the state of degradation of the ecosystem. And all of this we observed and used the in situ sensors and also the products obtained through remote sensing. So we have various sources of information that I will present in more details. So we have in the network two high-end sensors which are measuring beside meteorological data, also pollution data, nitrogen oxide, ozone, ground level ozone, and particulate matter 1 and 2.5 and 10 micrometers. So beside that, we also measure in the low-cost sensors meteorological parameters and solar radiation, and maybe the most important for the forest management is the soil moisture and soil temperature, which we also register beside the air pollution data. So what we aim to do and what we did with this data is to build a digital twin of this protected area. And that digital twin means that we have a copy, so to say, of this area in a high resolution and near real time. And we can visualize the wildfire risk and also to provide support for operational short-term measures and preventive and mitigation measures, and also long-term and risk mapping and climate change adaptation measures. The resolution of these maps is high, 10 meters. It is based on the Sentinel-2 satellite images. And also we use, when we don't have in situ measured data, climatic and meteorological data from reanalysis and climate models. So first, I will show the wildfire risk map, which is constructed using the following input data. So we have wildfire fuel conditions mapped based on vegetation flammability map. So we have a very detailed forestry survey with vegetation types that Ivana also showed earlier in her presentation. We combine this with vegetation density map and also with, so to speak, near real-time data from Sentinel-2, spectral indices, that is vegetation indices and wetness indices. Then we take into account the ignition risk. So Of course, as we saw in the earlier slides, the previous slides, the greatest factor for wildfire starting is the anthropogenic influence. So the built infrastructure proximity of the roads, houses, electric grid, and also population density. So right now, I will change to this screen. This is the interface of the fire risk monitoring system. I'm hoping that you can see it on your screens. And right now, this is hosted on Google Earth Engine as an application because it enables the most simple data calculation and visualization. But what we plan is to migrate this model entirely to our local server for Vojvodina Šume. That is a local server of Vojvodina Šume, geospatial server. So in this map, you can see in the interface, you can choose the time frame, which is the previous measurements, where we have a time series of previous measurements based on climatry analysis. That is the ERA5 land system. And by choosing the date, the year, and the month and the day, we can obtain the fire risk map on that particular day that was registered. So we can identify some parts that are critically endangered. So this fire risk map actually shows an index that is a relative fire risk index, and it has 10 categories, so ranging from low fire risk to medium and high and very high fire risk. So we can identify parts, and this is where the Vojvodina Šume can, in some occasions, limit the access perhaps to visitors to these areas or issue notifications and warnings for visitors and inhabitants of the surrounding areas when the conditions are critical and dangerous for wildfires. We can, of course, see this map, and what we also get by modeling wildfire throughout many days and months and years is that we can identify parts that are constantly endangered and perhaps focus there with the preventive measures, so leaving these fire roads open and clean, because this is a very long network of roads which can occasionally be also overgrown by vegetation. So this can help to the management to pay attention to those areas that are most endangered. So the next part is maybe the most interesting and most important part is the forecast. So we have the opportunity to see the situation in the 15 days ahead based on the meteorological data that is available. For this purpose, we use the ECMWF near real-time weather forecast data, and that has a 15-day forecast window. And here we have the parameters of air temperature, dew point temperature, relative humidity, vapor pressure, wind speed, solar radiation, precipitation, soil temperature, and soil moisture as given by the meteorological forecast model. And for instance, we can see now maybe for tomorrow what is the risk forecast. So right now the weather is quite rainy in Serbia, and as we can see, maybe it's a little bit small. So tomorrow the temperature will be around 14 degrees, and there will be a moderate wind and no precipitation. So we can see that the risk is ranging between very low and low into the maybe perhaps medium area. Also, we can perhaps see the 1st of May, which is a popular public holiday when people like to go out and have barbecue, and to see if there is some, but right now the forecast is saying that we will probably have rain and quite substantial rate. Actually, it says 50 millimeters, which I doubt that it's accurate, but it is very far away in the future. So I'm sure that this forecast will be updated in the next days, and we will have a more realistic picture. So here we see that there is no risk because there will be huge rain is forecast for that day, but of course that may vary. And of course the weather forecast is more reliable on some dates that are closer to the present moment. Okay, and the third time frame, so to speak, is the long-term climate prediction. And here we can see the map based on different climate scenarios and different climate models. So just to give you a few details about this model. This model is accessible through Google Earth Engine, and it is the CMIP-6 climate projection model based on NASA CMIP-6 ensemble. That means these are multiple model outputs, which are then calculated for the median output. And we can compare it with historical data and the future prediction. And in this model, it is done through monthly aggregations. So we will use the future prediction of air temperature, precipitation, relative humidity, solar radiation, and wind speed. So this is aggregated on monthly level. And we have, for instance, this is for the July month in the period of 2031 and 2041. So we can very easily implement any climate model in this interface and change the scenario. We have this scenario. So right now, this is the, so to say, optimistic scenario of climate change, but we can change it to some other, so to say, less optimistic outcomes of the climate change. And so this is the SSP 245 is the moderate one, where the intermediate greenhouse gas emissions are partially stabilized, and we have a moderate increase in temperature and fire-prone conditions. And the other one is the high-end or not so optimistic scenario with high greenhouse emissions and strong warming and significantly increased fire potential. So maybe sometimes this is calculated a bit more slowly, but we have a detailed picture. What I have to emphasize is that this presumes, this map, that the vegetation has not changed and the risk factors are not changed. So this is not a dynamic model of the vegetation change that will occur. And in that sense, it can be improved, and we will work on it to improve that we have maybe a more realistic future scenario for the vegetation spatial distribution, so to say, under specific climatic conditions. But all in all, this is the fire risk map that can be accessed and used by the management to address the problems of wildfire. Also, we have the drought mapping system where we actually follow the state of vegetation through by observing satellite vegetation indices and wetness indices. And this is one example where we have the NDVI anomalies, so to say, the deviations of NDVI values from the usual average condition of the vegetation. So we can pinpoint and spot some new developments on the ground and constantly monitoring this change through satellite images. And also, as mentioned previously, since we are slowly but surely running out of time, we have to address also the air pollution. And what you see is the measurement data in two locations, which are located. One is on the southernmost side, that is the Marina location. I will show it on the map. So this is by the Danube shore. This is the location of one sensor, and the other one is near to the central parts, more close to the central parts of the area. That is the Čardak location. So here we see the daily median value of PM2 particles, and what immediately is visible that it's not really very well correlated on the two locations. So we have some specific and local pollution sources in one location. And also these spikes, if we analyze the yearly distribution, we can see that the highest values occur in the winter time. So we can conclude that this pollution comes from housing, from individual fireplaces and so on. So that this pollution comes from mainly the population. Also, the PM10 is showing very similar patterns, very high winter values and much lower values in the summer. Recently, we had a big, so to say, cloud from the Sahara, so sandy pollution cloud coming from the area of Sahara, which is really the primary goal of our project. And we cannot identify on these graphs a very strong signal of that pollution. So fortunately, we are far away from that. So not like unlike in Cyprus or in Egypt, where that is a huge problem, we cannot register much of these pollution signals in our area. About the air pollution of nitrogen oxide, this area is considered very clean, but also it is surrounded by industry and the big urban centers. And so it is interesting to see that we do register elevated values of nitrogen oxide. So Ivana mentioned that we have already existing meteorological data which measures air pollution. And the only indicator that is measured is ozone. So these other indicators like nitrogen oxide show that really the area is maybe not so pristine and clean after all, and that we do register mostly. So this is the summer part of the year and the early autumn part, where we have elevated values of nitrogen oxide, which comes from fuel burning and also from fields burning and so on. So this is something that we have to look into more, what are exactly the sources of this pollution. A similar signal of, interestingly, ozone, and the two stations are pretty much in correlation. So we see that we don't have specific spatial differences in this regard. and this is quite universal signal throughout the Deliblato Sands. And for the end, I think this is the last indicator that I show you. And since we don't have much time, I will thank you for your attention, and please feel free to ask questions, and also any suggestions from your side or invitations for further cooperations are very, very welcome. So thank you.